purpose of this project was to simulate a Turing machine in Haskell. So to do this, I first had to create an abstract syntax for a Turing machine in Haskell. So the abstract syntax consists of two main parts, the first being the configuration, the second being the state machine. The configuration consists of what does the tape currently look like, which is represented in the tape type, and also what current state are we in for the finite state machine associated with the Turing machine. The state machine is a mapping from a label of a state to the transitions associated with that state. Transitions are just upon seeing a certain symbol, what symbol do I write, where do I move, and what state do I go to next. So after defining the abstract syntax, I then had to figure out how to parse input text, which can come in the form of this, where there are descriptions as to what to do in each state and also initial tape configuration. Once seeing this type of text, how do I parse it into an abstract syntax in Haskell? So to do this, I took to using many of the same concepts as we seen previously, and I even used the same parser base and parser combinator files to parse. And this all led me to create a description parser, which made up these mini lower level parsers that is able to take text like this and turn it into the state machine and the configuration, which we saw previously in defining the abstract syntax. So now that there's a way to go from text describing a Turing machine into abstract syntax in Haskell for a Turing machine, we now need to find out a way to run initial configuration on the Turing machine in Haskell. So to do this, take to the TM evaluation file, and there are a number of operations defined on a tape so that we can be able to run configurations on the tape. So the first is read T, which gives you the head of a tape, write T, which writes a certain symbol, and move T, which moves a certain direction. So these are all so you imagine, think back to when we were starting Turing machines. Read T is able to give you the current symbol, and then after seeing a certain symbol, we then write a certain symbol, and we move in a certain direction. We also go to another state. And so write T gives you the ability to write whatever symbol you want to write, and move T gives you the ability to move to a certain in either direction after seeing another symbol. And so these all help facilitate and actually running input configuration. And so this all combines into simulate, which just takes a tape and some transitions in a state machine, and it runs an initial configuration in the Turing machine. And so this all goes into actually being able to define the program, which just simply takes text, transforms it into a Turing machine in Haskell, and then runs a Turing machine in Haskell. And so this does exactly that. First parses input text, and then when it gets the state machine and the configuration from this input text, and then just runs simulate as we saw in the previous file, and then also converts it into a string just for ease of reading. And so we can see that if we were to run this, if we run this example in our program, then we get the expected output. So the initial tape here was this, and we expected in with this tape, and the initial tape as given by our program is this, and we end with this tape. So I was successful in simulating a Turing machine in Haskell. Thank you.